So we said, and we talked about this 2 times ago, that Gaussian averaging was a reasonable thing to do if the noise was independent in each pixel and it was centered about 0 so that the noise was created by a Gaussian process. So some were positive, some were negative, etc. And now we've talked a little bit about how they're doing the filtering. But there are other kinds of noise as well, and we need different kinds of filtering, maybe not a linear filter. That's why it's at the end of this lesson, just to show you something that's not linear but an effective filter. Okay? So on the left here we have that pepper image with a little bit of Gaussian noise added, and on the right we have the pepper image with the salt and pepper noise. Different peppers. Peppers as in good peppers to eat, with salt and pepper noise, which spicy pepper, black. The question is, what kind of filtering might you need to use on the right-hand side? Okay? So the way to approach this is to remember that our other assumption about images, right, is that the underlying image changes slowly around the pixel. So the idea is if there's some sort of arbitrary value that was put in some location, as what happens in salt and pepper noise, how could we go about finding the value that we should replace that value with to make a better picture? Now remember, when we were doing this filtering, this blurring, we were essentially replacing the pixel values by the local average, and it was either a box average or a Gaussian average. And that was fine when the noise was not a huge amount of noise, and it tended to go to 0. So by averaging, you tend to average away the noise and to get about the right value of the pixel. But if a few sort of totally random values are being injected into your image, you really need to do something different. And as some of you know, is when I have sort of these very spurious values, an interesting way of coming up with sort of the appropriate middle value is not an average, but a median.